Hi MATHSPRENEURS, welcome, keeping my word. Laws of indices and laws of logarithms. A to the power of m times a to the power of n is always equal to a, the base, to the power of m, the first power, plus n, the second power. If there are many more, multiply or divide, then you have to continue onwards, upwards there. Okay. Number 2, we have a to the power of m divided by a to the power of n. This is the 5th day, if I'm not mistaken, of Shawwal. 8 Ul-Fitr. Yesterday at the bank I saw 8 Al-Fitr, and then down there Mubarak, so it's 8 Mubarak. Selamat Hari Raya. So they're all celebrating here, still happily enjoying, all living in peace. So we hope all will be able to live in peace the world over. This will be a to the power of m minus n. Normally they have a 1 month, 30 days of celebrations, 31 days. Then that's the first variation. The other variation is 1 becomes a numerator upstairs, and the other one becomes a denominator downstairs. Same. Sometimes you'll see questions being set like this. So whether it be the first case or the second case, the answers are the same. Please take note. Number 3 is very easy. How so? So as I mentioned earlier, actually I have created other videos like episode 3, episode 4, 5 and even 6 I believe. Then when I played back episode 2, I said in the next video I will give you in one page only. So I came back and created these. So over there I'll be mentioning on that actual day of Shawwal, 1st, 2nd, 3rd, 4th. So this one is the 5th. Okay? So hope you know why the numbering seems to be like that. Okay, so this one is a to the power of 0. Very easy. It's not 0, it's not a, it's a straight 1. Law number 4 of indices is you open a curved bracket, you write a, we are using capital A here, and all the other letters powers are small powers. Then you put, small letters, you put small m, first power, then the second power outside the curved bracket, closed one is an n. So the answer is very simple. Just remove the first curved bracket and the second curved bracket, the open and the closed curved bracket, and just write back what you see. What we see is a, then to the power of m. Of course the n would have come to the right a bit, so bring it back nearer the n. If numbers are involved, just multiply them. Let's say 3 times 7, just say 21, like that. Then after that, so how to remember the pink colors will always have a and one more a. A, and one more A. So A, and one more A. So 3 A's will be there. The yellow one will only have 1 A. Then here is a number, then 1 A, it came back to a 1 A, or a 2. One on the left, one on the right, or one on the at the top, and one at the bottom. Blue will involve fractions. The reciprocal of n. The reciprocal of n, reciprocal, is 1 over n. Not the inverse, yeah? We will be using the inverse for logarithms and all that. So this is reciprocal. The answer is very straightforward. You see the base A, you write back the base A. Anytime and every time. Remember? Anywhere and everywhere, anytime and every time is a new one. Okay? The moment you see 1 over, that over from here, you just bring and put over to here. Then here, just follow the A only. Put a V shape. This and the denominator will come and locate exactly at this place here. It's read as nth root of A. Number 6 is similar. It will have all these things except with something on top. So allow me to write that again. Then I'll introduce that something on top. So it is still, I will still put it as 1 over n. Similar to number 2, one variation, second variation. So this will also have 2 variations. The one variation I will write to the right, as this one, to the right. The other one I will put to the bottom or somewhere, I'll bring it up, don't worry. So you see the A, you write back the A. The base must return, come back. You see 1 over, so carry over here and say over. Draw a parallel line. If it's a number like 3, you cannot draw a parallel line. Just draw at this angle and put a nice one, V there. Bring this n over here, as in number 5 above. Good. Don't put the n at the tip of this V here or outside. Never do that. So I need another one. Another one also I will put down here. Okay, which will be A. Then I said this 1 over, that over, you just remember it always as over, and then you put parallel to A and do a V shape over there and bring that n inside here. Done. So far, very good. Now, to emphasize a point, I want to use like multiply by m. So 1 times m will be m, or m times 1 will still be m. This m will really have to come next to the A. So go to A. See here, A up there is an m. So go to the far end where you see the A and join it back to where the m is. That's all. This will be 100% correct. Full marks. Similarly, this one is the same also. So I will extend here, but just create some space outside here, outside of m, and then you can do like this. Can you see a bracket there, there's some space there. That space there, you put a close bracket. That's all. That's all. Full marks, 100%. Now comes the green one. Now what happens is this. This one, number 5 and number 6 will also be here. It will become 8 and 9. So there's something I want to consider. I used green last time, now I want to use a different color. Look at number 7. Something is going to happen. A will be the base. So far that something hasn't happened. N will be the power. So far that something has not happened. Here is what is happening. Aha! A minus. Here you see the powers are all plus plus. You can put plus minus plus minus, but here we want to specifically tackle this type of questions, solve this type of problems, which is a to the power of minus n, the power that what will happen. Very simple. I used to sing a song. The wheels on the bus go round and round, round and round, round and round. The wheels of the bus go round and round, all through the town. And then go and make it vertical like that. This one, you just see it as an elongated division sign. After that, there's the same. Whatever you see up there, I see A, you see A, write down. You see little n, I see little n, write down. That's all. That is the thing, meaning what I'm focusing on is this one. Watch out for this one. Oops, I don't want that color. I want pink because I use that pink. Watch out for this one. Bigger. It must always become the division sign. It must always be 1 over. That's all. That's all. All the rest will be the same. So same thing here. If I put a minus, then it becomes 1 over. If I put a minus, it becomes 1 over. If I put a minus, it becomes 1 over. That's all. But since I didn't create any space there, I did create last time videos where I put straight from here. The moment I know this, then if I put a minus, it's just 1 over. If I put a minus, it's 1 over this. And if I put a minus, it's 1 over this. But since I didn't do that, why not I create now with what I call the green. So take care of the green here. This time it will be a little bit bigger. 8. Whatever is in the blue will repeat in the green here, 8 and 9. I'm going to repeat. A. Too big. I'm going to repeat, which will be A to the power of 1 over n. Only thing now is minus. So just say 1 over that. That's the answer. Very easy. The moment you see minus is 1 over. So just go and put 1 over. Meaning the 1 over represents or has taken the place of minus the power. So A to the power of 1 over n is this one, nth root of A. Just write back A. And then nth root. So here, and then we go, open a little bit bigger, try to pack in the n inside. Okay, it's still inside. Very good. Number 9 will be 2 variations. Same thing that you see in number 6. Just put 1 over because we bring in the minus. So let's go. A to the power of minus m over n. So the minus, now we have already solved over here. The minus means 1 over. The wheels of the bus go round and round. Remember the song? Yeah. So got 2 answers. First answer will be 1 over this first one. Which is the The first one is the nth root of a to the power of m. So write a put the thing over. Okay, you don't join them up like that. Actually, I should not join. It must not be joined up there. So put a little bit down here. Now what happens is that we have the over there. Good. We bring the root over here. Open up a bit. Come up here to balance it. Bring in the n here. And then the m will come outside. Yeah. There. Locate it or place it near the m. 100% correct. So this is one answer. The second answer will be here. Equals to, same, the negative is 1 over same 2, it is nth root of a. So a is there. The over there means the nth root parallel to a. Make it bigger. Place or locate the n here. This time around the m comes a little bit outside. And there should be a bracket here. That's all. Full marks. Those are the laws of indices. To make it clearer, the moment this negative came, there was a 1 over. So the moment this negative comes, there is a 1 over, and all the rest will be the same. The moment the negative power, the negative comes in, it is 1 over. So that's very clear. Of whatever was before, or were before. The moment the negative comes, it is 1 over. So we are 100% correct here. In effect, we just need to know this pink color, this yellow color, and this blue only, plus this one more. After that, the moment you put minus, just put 1 over that and 1 over that. If you put a minus here, it's 1 over this. If you put a minus here, 1 over this, 1 over this. So go back to the smaller pen size and say one way is this, the other way is this. You can put that equal if you want, okay? No worry. 100% serious. Now, allow me to use only this one and try to pack in somewhere here. Hopefully I can get all. Should be able to. Number 10, I even said at the last one I will use a smaller one. I think that is not required now. Just this is sufficient. This time to go for LOG. That one I use AB. Why not we use PQ? XY also can. YZ also can. Anything also can. Okay? MN also can. No problem. Why not we use XY? Log of X, Y. That means there's a times in between there. So the answer is very straightforward. It's equal to log take the first quantity, which is x, and then plus log of the second quantity, which is the y. 100% correct. Sir, where's the base? Teacher, you forgot the base. student, this base can be whatever, and the other student, this base can be whatever. If it's whatever W, you put W here, W here. If you want to take 10, you put 10 here, 10 here, base 10. Or you can put E, small letter E, not capital, yeah? You want to shorten LOG base 10, you put LG. Yeah? LOG base 10, put LG. LOG base 10, you put LG. You want to shorten LOG base E, then you put LN. You want to shorten LOG base E, you put LN. You want to shorten LOG base E, you put LN. Can. But we are standardizing. Any base that's allowed can come here, subscript, downstairs here. Subscript, the same base must be here, and the same base must be here, subscript. Okay, number 11. Okay, that's my nephew's daughter, also taking exam this year. Equivalent to the GCE exam. 5th form. Whoa, now she's relaxing, watching TV. This is a Saturday night. 11:33 p.m. 5/4 is April 2025 GMT +8 Greenwich Meridian Time. They pronounce it as Greenwich Meridian Time. Alright, now the next one has two-parter section, meaning has the two-parter section. From XY we go to YZ. Okay? Nope. Cannot, that one. We put a divide over here. Now, please do not be so confident and go and write there log y minus log x, because it's not true. If you just write like this, it is only log y. This log does not belong to the z. Z is just z only, no log there. Therefore, we need to do something. What is the thing we need to do? If you want to include the z, you must put them in bracket. Bracket, of course, understood whatever is the base. Then you can proceed confidently and go and put the first letter, which is log of the first letter there, the first quantity, which is y. Then divide here is looks like a minus. Yeah, the times will always be plus, friend, buddy, that my divide will be minus, buddy, friend. So you go and write here log y, 100% correct. I have to warn you, you can master the formulae 100%. But even after knowing the formulae, you master the formulae, to do the sums themselves, or those sums is another ball game altogether, many a time. Meaning that's when the tire hits the road. You are prepared, but this time the tire is hitting the road. When you come to write, you know the law, but then you don't know how to move here, move there, maneuver yourself and all that. So don't just say that I have mastered the formula, I am in the 100% gang. Yes, you are. Formula wise, you are 100%. You have mastered, but the doing wise, not yet. It's called practice makes perfect. So there's another one under the log. Take the letter after Z, we'll take A. Okay. And then we can use letter B. That one, to differentiate, we put a small b. We can even put m or whatnots, but don't put 0. The moment you put 0 or O, it becomes a to the power 0 becomes 1. It's another story altogether. So this one is very easy. The B, you just move. So the B, you just move to the front. So it will now become B. And whatever you see, since the base, the B, not the base, the power has taken the front portion, then remainder, you just follow it through with the log A. How? We will do all the proving. Okay, B log A. It looks like block A. Easy to remember. You want to put a letter V there, become V log log A. If you want to put a letter M, you become log. What is that? Okay. Now number 13. Number 13 is like this. Log of 1 can be any base. So the answer is 0. Teacher, how teacher? Sir. Where do we get the 0, sir? Okay, student, I'll give you the proof. Okay? In future videos. Number 14, this time around, you need the number and the base to come up to the answer that they expect once they give that. So what letter do you want? We use capital T. Log of T, and the same T, you know, not small t, you know. T for Tata. The answer is 1. Tata in Tamil, the Indian language, called grandfather. So Tata. Number 15. Ooh, seems to be tough, huh? There is a log. Take any letter you want. T there. So why not we go forward? R S T. Why not we use R? And then why not we use S? You spell the capital S. And then that's how we speak over here. Our local lingo is very surprising. Allow me to bring this color in. This one, SRRS, you can put 1 over, provided you change something. And what thing is that? You, go back to this one, interchange their positions. Meaning, whenever you see that letter, whatever letter interchange with the other, this one, R, you put over here. It's something like matrix where they say transpose. That word transpose, T-R-A-N-S-P-O-S-E. Oops, Daisy! I say and I didn't do it. They move over. Matrix has a different meaning. I mean, meaning is like you move over, but you see that it has different format. But this one is just simple. The R goes downstairs, the S comes upstairs. Not denominator, numerator, just changes position. Can be proven. Very easy to prove too. So now it becomes 1 over S to the base of R. Of course, they are all same, like big letters, but because you want to put as the base there, you make it like small looking, but they are all the same, like R and R are the same. The S and S are the same. Okay, this is very strange here. Number 16 is, I gave you the other one. Take a little v. Go to the power portion there. Master it, yeah. Slow and steady, but get it into your minds, the recesses of your mind. And there, you put back the base also as the v, the same v, you know, small one. And then the number there is a big V. Of course, we can use different letters. I don't want to confuse with too many letters. Just V only, like that. Number 7 follows similarly. I mean number 17. Follow similarly. Put the little v, very clear. Go up to the right, write the log L-O-G, wait, it's a bit too far, the O, L-O-G, then after that, to this L-O-G, give a base, the same one, there I show you. The same V must come here, small v only. If you use A, B, C, D like that, many letters will come in, might be a little bit confusing. Some might find it easy, but it might be confusing. Just remember this only. There's a little v and little v here. Then put a big V there. It's called log of V. And then to that log of this big V there, give it the power of small v. So there's a variation here. Little v, log, log, base v, base v. The thing there after that is a capital V, a capital V. This V has a 1 power. This V now has V. Little v like that. Got it? Look very carefully and compare. Little v, then both have a log. Up there has the power, log up there has the power. Of course, that log needs to have a base. We introduce back the same v, the little v. Okay, taken care. Then we put a capital V, here also capital V. Then for that one, we give a power 1. No, they won't put actually. Actually, they won't put a power 1. It's understood, you should know. But this one, they need to, you're going to put some power, put a little v there. Meaning, the little v also comes up here. Whoa. That's a highway nearby there. Speeding like nobody's business. Woo. Pray they safely reach home. Whoa, no joke. So, one little v, another little v, another little v. Good. Then one capital V. The answer. The answer, drum roll, is drum roll, it's just this thing. Just transfer it to the answer position. That is the one. So, that's all. Teacher, how student, wait So, this time, I'm going to put like this. The answer is just this one. How teacher? How sir? Others will ask. Wait I will answer them. I will show you how to prove. We will prove together. Okay? Yeah. Very, very important. At the count of 3, follow, and then we will do slowly first, then we'll do a little bit faster, Very important. 1, 2, 3. A to the power of m times a to the power of n is equal to a to the power of m plus n. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. A to the power of m, everything over a to the power of n is also equal to a to the power of m minus n. A to the power of 0 equals 1. Open curve bracket, a to the power of m, close curve bracket, to the power of n is equal to a to the power of mn. A to the power of 1 over n is equal to the nth root of a. A to the power of m over n is equal to the nth root of a to the power of m. A second variation is a to the power of m over n is equal to open curve bracket nth root of a close curve bracket to the power of m. A to the power of minus n is equal to 1 over a to the power of n. A to the power of negative 1 over n is equal to 1 over nth root of a. A to the power of negative m over n is equal to 1 over nth root of a to the power of m. Another variation is a to the power of negative m over n is equal to 1 over open curve bracket nth root of a close curve bracket to the power of m. Log xy is equal to log x plus log y. Log open curve bracket y divided by z close curve bracket equal to log y minus log z. Log a to the power of b is equal to b log a. Log 1 is equal to 0. Log t to base t equals 1. Log r to base s is equal to 1 over log s to base r. Little v to the power of log of v to the base of little v is equals to v. Repeat. Little v to the power of log of capital V to the base of little v is equal to capital V. Little v to the power of log capital V to the power of little v all to the base of little v is equal to capital V to the power of little v. Do you want to speed? I hope we don't have to speed. After it will be very confusing. But if you want to go at breakneck speed, we'll try also. Marks, get set, go. A to the power of m times a to the power of n is equal to a to the power of m plus n. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. A to the power of m all over a to the power of n is equal to a to the power of m minus n. A to the power of 0 equals to 1. A to the power of open curve bracket a to the power of m close curve bracket to the power of n is equal to a to the power of m n. A to the power of 1 over n is equal to n root a. A to the power of m over n is equal to n root a to the power of m. Another variation is a to the power of m over n is equal to open curve bracket n root of a close curve bracket to the power of m. A to the power of minus n is equal to 1 over a to the power of n. A to the power of minus 1 over n is equal to 1 over nth root of a. A to the power of minus m over n is equal to 1 over nth root of a to the power of m. A to the power of minus m over n is equal to 1 over open curve bracket nth root of a close curve bracket to the power of m. Log xy is equal to log x plus y. Log open curve bracket y divided by z close curve bracket is equal to log y minus log z. Log a to the power of b is equal to b log a. Log 1 is equal to 0. Log t to the base t is equal to 1. Log r to base s is equal to 1 over log s to base r. Little v to log of capital V to the base of little v is equal to capital V. Little v to the power of log of capital V to the power of little v to base of little v is equal to capital V to the power of little v. Whoa, not easy. But most important thing, you must understand that. If not, there's no way. No way. Okay, you have done a very great thing, a great achievement. Those who have followed every video, not even missing 1 minute, you have come up to the top of the top. I have no more formulae to give you. Seriously, yeah. I have no more formulae to give you. these are the formulae. Yeah, of course there are curves and graphs and all that I will give you, but these I want you to know, especially the last two might not come out in exam. Any which way you be prepared. Okay, don't be lackadaisical, take it easy and say never mind, it won't come out. Who knows? Who knows? Okay? That's like that. Wait. So you have now reached the 100%. So feel happy that you have come up to this level of from zero, you know. Remember last time you were like, people had run you down, that you are like, cannot. They say you cannot do it, you know. And now, like last time people run you down, they say you cannot do it. But you see, you have stuck on faithfully, you have not given up, you never say die, and then you fight it all out, you know, for this education thing. You say, I can do it. Yeah, it's tough. Never mind. I will go right till the end. And actually you have reached K2, Mount Everest K2, the highest for your maths indices and logarithms. Wow. Time to celebrate. Congratulations and celebrations. Da da dee da dee da dee da dee da dee dum. My voice. Param pam pam pam. Param pam pam pam. Da da dee da dee da dee da dee da dee dum. You deserve a pat on your shoulders, yeah? Serious. Since you have come from the zero stuff where people run you down and say you can never pass, pure maths. Remember my video one? Now you not only can pass, in fact I should say you will never pass pure maths or at maths. You will score, as I told my students, 5 or 6 girls. I went, started the class, I said, I have something to tell you. So they looked intently, earnestly, and I said, none of you will pass my class. They said, yeah, teacher, so bad, huh? Teacher, so bad. I said, wait, hear me out. Yeah, none of you will pass my maths. I mean, pure maths, at maths, all included. Because they were pure maths, they were mathematics students and additional mathematics students. They took both. So I said, none of you will pass, but I want all of you to get the A. You see the expression of relief and, you know, even joy, you know. And people say, yeah, teacher, you're so bad. But actually, I said, none of you should even pass my maths. I'm not interested in the pass. Though I respect it, no. We are not going for that. We are already from the 0 to 10% to 20% to 30% to 40% to 50%, then to 60% to 70% to 80% to 90%. We are already 100%. What remains is only to do sums, where we will make use of all these things, these formulae. We'll even give proofs for those, proof for every single one of it. Every single one. Remember I told you last time? Yeah, every one we will prove. We will also have so many sums until, whoa, 100% is, as they say over here, dalam tangan. Dalam means in. Tangan means hand. In your hands. Okay? See your hands. No, I don't mean you go and see or whatever. Just say it's in your hands. Beautiful. 100%. God bless every single one. God bless every single one.